All right, Chemistry One Podcast. Welcome. Hello. Today we're going to go over the types of equations, and this will be very quick and simple. Basically, what we're going to do is we're going to do 5 simple chemical equations and be able to predict what the products are going to be because they always follow the same template. Yeah, pattern. So you ready to get started? First one that we have is called synthesis. All right, it's also called
photosynthesis.
Hey, good call. This is basically going to be taking something that's by itself, A, and another thing that's by itself, B, and we're going to combine them.
Smoosh them.
Okay, so the first one we're going to do...
I know 2 syntheses.
What kind?
Photo, protein.
Very nice. So you're taking smaller things and making big things out of them, right?
Yeah.
That's what we're doing here.
Cool.
You ready? The one we're going to use, the very simple one, is going to be the formation of water. So we're going to take hydrogen, which remember is diatomic. Very good. And we're going to take oxygen, which is also diatomic. Is there 2 elements that are separate? Yes. And what we're going to do is we're going to combine them, and we're going to make H2O. There you go. Now remember, hydrogen has a +1, and oxygen has a -2, which is why we needed 2 hydrogens to balance out that 1 oxygen. You always got to keep that in mind. Okay?
I think I know what decomposition is.
What's decomposition?
The opposite.
It is the opposite. A classic decomposition is H2CO3, also known as carbonic acid, found in your Pepsi and your Coke and stuff like that. And when you shake up a pop, what happens? What happens?
You open it and it makes a big fountain explosion.
It does. It makes a big fountain explosion. That's carbon dioxide coming out of solution. Now watch what happens.
Like a gas.
Yeah, like your definition of a gas. Okay, see how it's the hydrogen, the carbon, the oxygen are all together in one compound. So if you see one compound by itself on the left side, we know we're talking about decomposition. All right? So what happens is when that carbonic acid gets in solution, it naturally will break apart into what?
Water.
Water and
CO2, carbon dioxide.
Carbon dioxide. Now you can see that there was 1 compound on the left and it broke down into 2 on the right. It's decomposing like a dead body.
Yeah.
Okay. You ready for the next 2? Single replacement. I like to call this one the loser at the dance. Okay? So A walks into a dance and B is dancing with the girl X. But A is cooler than B, so X decides to leave B and go with A over here, and B is stuck by him or herself.
That's okay, though.
It's okay to be by yourself. In order for this to occur, B is the loser, right? So that means A must be cooler than B. Now, in chemistry terms, we don't use cooler and loser. We use more reactive. Okay? In order for this equation to work, A has to be more reactive than B. And the way we figure this out is by using an activity series of metals. And it's on your cheat sheet. See if you can find that next to your polyatomic ions sheet. There you go. Do you see it?
Yep.
There it is. So they always have that available to them. So let's look. Lithium, being at the top, is the most reactive, or the coolest. All right? And way down here, we get chromium.
Iron got cut in half.
Yes, not very good. So chromium's not very reactive compared to lithium. So I'm going to give you an example of this, and we'll see how it goes. You ready? I'm going to take some aluminum foil, Al, and I'm going to react it in something called copper sulfate, CuSO4. So you can see that Al represents the A, the Cu represents the B, and the SO4 represents the X. So now let's look at our activity series of metals. Is aluminum on here?
Yep.
There it is. Is copper on here? This would be a horrible example then. Let's try again. Okay. So what I'm going to show you is a...
Copper on there?
It's on there. It's way down the bottom. Okay. See it?
Yeah.
Okay.
So gold is like terrible.
Yes, but that's why it's worth so much money. Because it doesn't react with anything.
So it's like lithium. They're like selling it to you, and then they're like, oh,
and it's gone.
Explodes in your head.
Yeah. All right. You ready? Okay. I'm going to react some lithium by itself with some calcium chloride. Boom. Like that. Notice I have 2 chlorines because calcium is a +2 and chlorine's a -1. What we're going to do is the lithium represents the A, the calcium represents the B, and the Cl represents the X. Okay? So, let's look. Here's lithium, here's calcium, right there. Is lithium more reactive than calcium?
Yes.
Then this will happen. Lithium will replace calcium and dance with the Cl2 girl. Okay? So now lithium will come over here.
Claudia.
Lithium will now be with chlorine. And who's out by itself?
Calcium.
Calcium. There you go. Now let's look at lithium and chlorine. What's the charge on lithium since it's in group 1?
+1.
+1. So I'll write a +1 above it. And what's the charge on chlorine since it is in group 17?
-1.
-1. Is that a neutral compound?
Yes.
That's good. Notice I didn't have the Cl2 over here because it's all about whether it's neutral or not.
They got married.
So guess what? Is it balanced? It is? Is there one chlorine on the left side and the right side?
No.
There's 2 chlorines on the left side and 1 on the right side. So that's where our coefficients come in. We'd have to put a 2 in front of that to give us 2 chlorines, but look, now we have 2 lithiums. So I have to put 2 in front of that, right? Make sense? There you go. The next type of chemical reaction is called the double replacement. And I like to refer to this as the wife swap. Okay?
Desperate Housewives.
There we go. So we have A with X. A is married to X, and B is married to Y. And what happens is A and B switch places. So now A goes with Y, and B goes with X. Make sense?
Yep.
Now there's no way that my students in Chemistry 1 will be able to predict whether or not these will happen, so we just will assume that they happen every time.
Got it.
Okay? Here we go. Let's go with an example of, copper chloride, CuCl2, cupric chloride if you will. And we'll react that with some, let's say, silver
Sodium.
nitrate. There we go. Boom. Okay? So now let's look. There's 2 parts to each compound. The copper here represents the A. The Cl represents the X. The Ag represents the B. And the NO3 represents the Y. Okay?
X5.
There we go. So let's switch them. So now the copper was with the chlorine. What's it going to be with now?
The copper is going to go with the nitrate.
The nitrate. So we're going to go ahead and just put nitrate here. Boom. Now, what is the charge on nitrate? It's a -1. I'll just help you out. -1. And this copper has a +2. So how many nitrates do we need to balance that and make it neutral?
1 more.
1 more. So we're going to put a parentheses around it. Oh, that's the worst parentheses ever. And make it 2. Okay, so the copper's now with the nitrate. Now let's go with the other one. The silver was with the nitrate, but now the silver's going to be with what?
The chloride.
The chloride. Very good. So we have that right there. Now silver is a +1 and chlorine's a -1. Are they neutral?
Yes.
Yes. Is this equation balanced though? We have 2 chlorines on the left side and we have only 1 on the right side.
No.
So we got to put a 2. See how we do? Once we write the equations out and the compounds are the right way, they're neutral, then you can't mess with them. You can only balance it by doing the coefficients. Now we have 2 silvers. What do I put here?
2.
2 over here. So I have 2 silvers. Now I have 2 nitrates, NO3s. So I have 2 NO3s over here?
Yep.
We do. There we go.
We are good.
We are good. Last one. It's called combustion. We saw this. That's how we started the whole thing off. You take a hydrocarbon, which is carbon and hydrogen only, react with oxygen, and it always forms the same 2 things, carbon dioxide and water. Okay?
That makes sense.
if you have a hydrocarbon and you react with oxygen, you get carbon dioxide and water.
No.
So let's do a perfect example of combustion. You ready? Let's do our respiration in our body. You excited? Here we go. We eat glucose, don't we? You ready? C6H12O. Want to take a guess? What's next?
18?
6. Glucose. We're going to react with oxygen. Right there.
Choo.
And what do we get?
Choo-choo.
What are the 2 things we're going to get?
We're going to get carbon dioxide
Good.
and water.
And water. There you go. Combustion always forms the same 2 things. And always. So the only thing that's going to change is this guy right here. That's it.
So now instead of chew, we have choho.
There you go. Is it balanced?
Yes.
It is?
No. The
We have how many carbons on the left side?
6.
So I'm going to put a 6 in front of this to give me 6 carbons over there. How many hydrogens do we have on the left side?
12.
How many? What am I going to put in front of here to get
A
12?
6.
Good. Now we got our oxygens left, right?
Mm-hmm.
So we've got
The oxygen's
6
okay.
plus... well, let's see. 6 times 2, we have 12 in this one.
Uh-huh.
And we have 6 times 1, so we have 6 in this one. That gives us 18 oxygens, right?
Mm-hmm.
We already have 6 here. 6 plus what's going to give us 18?
12.
12. 2, there's 2 of them in each one.
6.
Put a 6 there. More balanced. That's respiration. And that's it for this one.
Bye.
Thanks for watching. Bye-bye.